Good morning, everyone. So, today I'm going to talk to you about application design at scale. Now, before we get into it, I'm just going to clarify a few things. When it comes to applications and scale, what we mean basically is applications that have matured to the point where you have millions, if not, well, billions. So I'm going to be honest. I have never worked on an application of the size of Facebook, for example, where they literally have billions of users every single day. However, I do have some experience when it comes to having applications that are running for millions and hundreds of millions of people after my time at Ticketmaster. So I thought I'm going to share some of the things that I think that are very important for you as a single developer to have at least a high level understanding of in order to effectively work with systems of that scale. Now, this is going to be broad stroked, and I'll make a few videos about each topic, going more specifically about each topic in the future. But let's get into it. So, the first and foremost thing that is a large difference when it comes to applications that are running for that really large amounts of users is that it's not so much the application itself. Like, the code pretty much stays the same, the project pretty much stays the same. The most important thing I have found so far that needs to be considered when you're running something at scale is everything around it, the operations part of the system. Now, if you are planning on having an application or working on an application that is literally of that size, the first thing you should be aware of is cloud management. Basically, if you have no idea what I'm saying when I say Amazon, AWS, or Google Cloud Platform, or Azure Cloud, if you don't know any of this stuff, that's the first step for you to learn, because today it's fairly common practice to have one of these giant cloud providers run your infrastructure for you. Because the thing is that when you're running an application at the size where it's serving millions and millions of people, you can't just put up not just any old web host is going to cut it. You're going to need support systems. You're going to need logging, load balancing, caching, database. There's so many things that you're going to need, and these services are designed to help you with that, to run your, basically manage your application. Now, that's the first thing you should be aware of. The second thing is that when it comes to large amounts of people, performance starts to become an issue, and specifically two types of performance: memory and CPU. Those are the two main things that are going to be important for you to start thinking about when you have a really large system. Usually a memory is the thing that is going to, depending on what type of application you are, if you have like a high intensity computation system, CPU becomes more of an issue. But memory usage is, at least from my experience, what is like sorely needed. Now, the cloud platform providers usually have payment plans and so forth where they auto scale for you, so that if, let's say that you have an influx of a large amount of users, a good example is so take Ticketmaster. It's a good example. Whenever Ed Sheeran is here in Sweden, or anywhere basically, the influx of users trying to get tickets to his concert is massive. And on average days, maybe a load is fairly regular and standard, but then you have these spikes when somebody really famous is going to have a concert, because everybody wants the tickets and everybody gets onto the system exactly at the same time. And that's when you really get the sensation of difference of how it is to have a very large system as opposed to a small system. Because usually when you're if you're a medium-sized or small-sized company, you never ever experience a computer. Because think about it yourself. I mean, how many times have you felt that your computer can't keep up? that's exactly what happens when you have that large amounts of users. So that's where things such as containers and load balancing comes into play. Now, a container is basically a deployment, an instance of your application boxed up in a wrapper, if you will, that is going to be able to run in parallel with a lot of other instances of your containers, of your application. The reason why this is important is because the fact of the matter is that it becomes very, very expensive because imagine it yourself. If you have one single instance of your application running on a computer and there's millions of users all of a sudden coming to your system, then the computer that is running in the cloud and basically serving all of your users is going to have to scale vertically. It's going to have, and it used to be the case. You may have heard the word mainframe thrown around in movies, and that used to be the case because computers were extremely expensive to produce. So what you did was you built these supercomputers that everybody shared. But today it is fairly standard practice to have a lot of computers, smaller ones if you will, to run in a horizontal manner instead. So instead of having one big computer that runs several instances and serves and has massive amounts of memory, you have several small ones and then you kind of hook them up with load balancing instead. So if you don't know what Docker is, you need to check that out. Docker is very important for applications at a large scale. And if you have an understanding of Docker, you should have a look at Kubernetes. Kubernetes is absolutely amazing when it comes to Docker, and it's basically a management system for all your containers. It is absolutely vital to know this stuff. So these are the first three things you need to have a look at, and these are, as you may have noticed, all operations-based stuff. And then you go on to load balancing. What's load balancing? Well, if you have let's say that you have two instances of your own application running, and you have a load balancer. The idea of the load balancer is that the request from your user comes into your system, and then it switches between sending one request to instance 1, and then next user may be sent to instance 2. And the reason why you want this is because then you abstract away how many, then you can scale. You basically have a decider in front of all of your application deciding which instance the request is going to go to. And that's very powerful because when you have a really large system, high availability, a Ticketmaster, they can't just take down the site. You haven't done that in years. You can't just take down the site when you need to do an update. So what you do is that you let the load balancer point to one specific instance of these two. Usually, of course, you can have many more instances, but for my little example here, we're just going to have two. So you point everybody to the first instance of your application while you pull down the second one and pull up the new version of your system, or the new version with your updated code, and then you point the load balancer back to or you point the load balancer to the new instance, and you do the same thing for the old instance. So that's called a rollover, or like a rolling update, if you will. And so load balancers are a fairly important part of large-scale systems because you need to be able to because you need to be able to add and remove instances of your application without a lot of overhead work. Now, of course, if you use Amazon or Google or Azure or so forth, they will help you with this. So that's why I say that's the most important part, because all of this stuff that I'm talking about, you're going to have to learn in order to effectively work with these cloud providers. And the final thing that you need to be aware of when it comes to these systems is that you are going to experience, for the most likely the first time, that there is a timing issue, or there is a lot of latency issues, where, especially at the database layer, it's even if you write the most effective, amazing code in the world, you generally have one bottleneck, and that is the database. Because the database is, regardless of how fast your code is, the database is going to have problems keeping up in sometimes. And if you have really heavy computations, it gets really tricky to do that. So what you really want to do, if at all possible, is to delay producing results into batch jobs or scheduled jobs and so forth. And basically what that means is that a good example is emails. It's very inefficient for you to, like, if your user signs up to your, you may have noticed this yourself, that the email is always a little bit late or like a few moments delayed. And the reason in general why this is because this is the sort of thing where the user doesn't expect immediate feedback. Immediate feedback for the user is, okay, I put in my login credentials, I hit login, and then I immediately go into the application. That's what the user expects. But you can delay sending out an email a little bit, so you don't have to. Because if you have millions of people who are triggering email requests all the time, it gets really, really heavy for your system. So what's really nice there is that you take in the request and you basically put it on a queue. And a queue is just a way of basically telling your email service that, or rather not just your email server, but a queue is basically a way to save a piece of work, a computation, until the system is ready to receive it, so that you can kind of manage load. I will go more into queues and how they work in a future video, but that's one way you can do it, so that you don't have to have like an instant email being sent out all the time. That's one thing you can do. You can do other things as well, like statistics generation is another one. Like for me, for example, I use the YouTube Creators app, which generates statistics for my channel. And that's if you have used it yourself, you will know that usually it's 1 day delayed and sometimes 48 hours delayed. And the reason why it is because they are using batch jobs, because generating statistics is very heavy computation work. It requires a lot of resources because there's a lot of database accesses, there's a lot of basically calculations and all that stuff. And that's very heavy for the system. So it's much better for YouTube or Google to run a so-called batch job, which is one single really heavy computation that can take maybe hours, and generate the statistics and send that to me as the consumer. That's what a batch job is. And the reason why these things are very useful is because if you try to have everything real time at millions and millions of users, you will find that your system will very quickly become very costly for you, because you're going to have to pay for so much memory and CPU power to be able to do this. It just becomes very unfeasible very quickly. So these are some high level tips that you should, or concepts that you should look into if you want to work at scale.